Welcome to our first help video on Unit 2 test. If these help videos leave you confused or do not clear up any misunderstanding, please do not hesitate to contact me, email me. We can set up a Zoom session to go over any of these questions that are puzzling to you. On our very first few sections of the test, these are straight definitions. I will not go over these definitions. That doesn't mean you can't ask questions on the definitions, but with regards to the help videos, most of these are just straight definitions of terms. So if you are confused on the definitions, don't hesitate to ask. The first section, definitions. Second section is matching definitions. The third section is again matching definitions. And in the fourth section, it was important to understand that this was double matching. So on this section, you had to pick which definition fit with the four states of matter: liquid, gas, solid, and plasma. Then you had to pick the diagram picture that illustrated it. So on the left, you see the definition. That's over here. On the right, in blue, you see the diagrams, and that's from the diagram underneath there. So you had to pick two answers for those. If you have any questions on any of that, don't hesitate to contact me. 22 to 27 are also definitions of ways to separate mixtures. So we're not going to go over these questions in the help video. This is more straight definition versus understanding concepts and content. But if you have questions, we will be happy to address those. So just let me know through email, send me the number. We can correspond. Now, when we get to 28 through 31, these are worth going over in terms of understanding the concepts behind these questions. So the first one is wanting to know, on all of these, they're wanting to know, is this process exothermic or is it endothermic? You were supposed to mark A if it's exo. You were supposed to mark B if it's endo. So what do we need to know about exo and endo? Exo means you have to pull heat out of the system to the outside. You've got to pull heat from inside to the outside. You've got to cool it, essentially. And how do you remember it's going to the outside? Exoskeleton fits the word exit. Exo fits the word exoskeleton. Skeletons are on the outside. The word exo also looks a lot like the word exit. Heat has to exit the system. Endothermic means that you have to add heat into it. So the heat's going to move from the surroundings into the system. So in order to get the phase change to occur, you have to heat it up. Heat needs to go on to the inside. Endo. Endo sounds a lot like indo or inside. Where is an endoskeleton? It is on the inside. So for number 28, they're wanting to know, what do you have to do to melt something? Melting is the process of changing a solid to a liquid. So we're going from a solid to a liquid. We're following this arrow right here. Melting. If you want to melt something, you have to add heat into it. That's endo. So if you have an ice cube and you want to melt it, you have to add heat into it. What does that heat do? It gets the molecules of the solid moving faster, 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 faster until they can pull apart and start flowing around each other. You have to add heat in them to get them moving so fast that they pull apart and can start intermingling. Melting. Add heat into it. That's letter B, endothermic. The next question is about vaporization. Vaporization is a general term for turning a liquid to the gas state, which is a vapor. It can involve evaporation, which takes place on its own. Really, it uses heat from the surroundings for the molecules on the surface of the liquid. The molecules can get heated up and then they can fly off as a gas. They get heated up, they overcome the intermolecular forces holding them in the liquid, and they take off into a gas. But heat has to go into it in order for that to occur. Boiling is kind of the term used when you're making it happen. You're adding the heat and you're causing that gas to turn into a liquid, to move to a liquid phase. So in the case of evaporation or vaporization, you have to add heat into it to get the liquid molecules moving fast enough that they can fly off as a gas. You have to add heat into it. That is also endothermic. What about condensation? Condensation is a gas back to a liquid. A gas back to a liquid, we're following that arrow right there. To get a gas to undergo condensation, gas molecules are flying by each other rapidly. To get them to pull together as a liquid, you've got to slow them way, way down so that when they get near each other, they can pull on each other and return to liquid state. When it's a liquid, the molecules have to pull on each other. When it's a gas, they're going by too fast to pull on each other. So we have to slow them down. We have to lower the temperature. To lower the temperature, remember, temperature is the average kinetic energy of the molecules. So to get a gas to condense back to a liquid, we've got to slow those molecules down. We've got to move heat from the molecules, which is the system, to the outside. We've got to get heat energy to exit that system. We pull heat out of it. That's exothermic. Pull heat out of it. So condensation is letter A, exothermic. The next one, number 31, is asking about freezing. Freezing is when a liquid changes back to the solid state. To get a liquid to freeze, the liquid molecules are flowing around each other. To get them to freeze, we have to slow them down so that they can begin to line up in a regular organized state that we call a solid. So if you want to freeze liquid water, you have to cool it. Freezing, you would have to cool it. To get it to freeze, we've got to pull heat to the outside. When you're cooling it, the heat goes from the system, the liquid, to the outside so that it can become a solid. That's exothermic. Let's take a look at 32 to 36. Again, these are definitions, a lot of these things, but these are a little bit more concept type definitions. The Tyndall effect is that scattering of light by a colloid. A colloid has those tiny little particles flying around. A colloid would include something like a fog, where you have liquid molecules spread out among the gas of our atmosphere. And the particles are so small that when you shine light into the colloid, it scatters that light all over the place. That is the Tyndall effect, the scattering of light by a colloid. Diffusion is the spreading out of something from a higher concentration to lower concentration. That is correct. Diffusion. So gas molecules are moving randomly about. So if I have in this container right here, I have like a perfume. If I take the lid off that perfume, the liquid molecules may evaporate into the gas phase, and that perfume will begin spreading out throughout the room. That process is called diffusion, letter A. Gases and liquids are states of matter that are characterized as fluids. That is true. Fluids are anything capable of flowing. The changing of a gas into plasma is called ionization. That is true. Changing of a gas into plasma is ionization energy. What is plasma? It is ions. When we have a gas and we keep adding energy to it, eventually the energy is so high that the electrons that are orbiting that atom fly off in a stream. So we get a stream of negative charges flying off the atoms, leaving behind the positive nucleus of protons and neutrons. We ionize that gas to form a plasma. The energy needed to start a chemical reaction is called latent heat. Actually, no, the energy needed to start a chemical reaction is called activation energy. That's the activation energy is the energy you have to add to snap the bonds of the reactants. The reactants, the atoms on a molecule or ions in a salt crystal, are held together by chemical bonds. We have to overcome that chemical bond by adding energy to break the bonds so that those ions or those atoms that are broken off a molecule are free to react with other substances. That's activation energy. On the next one, we're looking at chromatography. They spotted a green color That was a mixture on this line. How do I know it's a mixture? Because I see the green here and it's separated into yellow and blue. So this chromatography paper was put in a solvent. The solvent moved up the paper. The green color was pulled apart into a yellow pigment and blue pigment, which made up that green. So 37, is green a mixture? Absolutely. The green, it started out green. As the solvent pulled up, the solvent pulled the green mixture apart into yellow and blue. Number 38, the yellow is more attracted to the chromatography paper than the blue. That is true. As the solvent went up, the solvent pulled the yellow to here, it pulled the blue up to here as the solvent moved up the paper. Why didn't it pull the yellow up as far? The yellow wasn't as attracted to the solvent as the blue was, and the yellow was more attracted to the paper than the blue was. So the way this mixture is pulled apart is by the various attractions they have. The more attracted it is to the paper, because of having similar intermolecular forces, like intermolecular forces attract likes, the yellow was more attracted to the paper than the blue. The blue must have had intermolecular forces more like the solvent, since it went further up the paper. From the chromatography above, it is evident that blue is a mixture. No, it isn't. If it was a mixture, we would see the blue getting separated into other colors. The blue didn't get separated, so it's not evident that blue is a mixture. Number 40, if the green did not separate at all. In other words, if the green spot just stayed here as the solvent went up the paper, it would be possible that this green dye was not attracted at all to the solvent. And that is true. If the green dye was attracted to the solvent would pull it up the paper as the solvent traveled up the paper. 41 through 44, our final questions right here. Let's take a look at what we have here. 41, what's whipped cream, mayonnaise, fog, smoke, mist? That is tiny little particles that remain suspended. Gravity doesn't pull those out. They are mixtures called, letter B, colloids. Salt water is a homogeneous mixture called a solution, letter A. Tomato juice, milk with magnesia, which is like Pepto-Bismol liquid. Letter D, those are suspensions. Those are suspensions. Why? Because you have to shake them up. In a suspension, the particles are bigger than a colloid, but they're not so big that they immediately separate. A suspension, they stay separated for a while, but eventually the particles are big enough that gravity pulls them down, and you have to shake it to mix them up later. Glass containing sand and water immediately separate. The sand will go right to the bottom. When they separate immediately, where they're so big that gravity pulls them down right away, and when they're so big that you can see them easily separated with your eye, that's called, letter C, a mechanical mixture. This will conclude our first help video. If you have questions on the remaining portions of the test, hang around for the next video.